So what we're going to be discussing right now is agarose gels, for which you will use to resolve DNA. Agarose is a media that makes a tightly woven knit pattern and allows for us to differentially run things according to size. So on a gel, the smallest things will run faster and the largest things will run slower. So this is our gel setup. As you can tell, we have a particular area that we run the gels in. This is because the intercalator that we use to actually see the DNA on the gel is a carcinogen. Hence, you're going to be wanting to wear gloves and a coat at all times. Anything that's marked in red is for use on those gels, including flasks, pipetters, and the setup themselves. So we have two different sizes of gel reservoirs. This is a small reservoir. This is a large reservoir. This is our power box. And these are actually what's going to deliver the power to that reservoir. So to begin, most of you will be doing a 1 to 2% gel. That means that there is 1% agarose in a media. That media is actually a salt buffered solution that will allow electricity to flow throughout that gel. So what you're going to first do is measure out the agarose that you're going to need. And you're going to do so using an Erlenmeyer flask labeled gels, agarose medium, which we typically leave on this shelf. And then we have a drawer here called Weiboth Supplies Agarose Gel Supplies. So in here you'll actually find the different setups. And so you'll figure out, based on how many wells you're going to need, which setup. So we're going to do the small setup today. So what you'll need is a small gel caster. And you'll also need what's known as a comb. And that comb actually fits nicely right into this. Additionally, you're going to need the intercalator. And this intercalator is called GelRed. So what it does is it binds in the minor groove of the DNA so that we can actually see it under UV light. You'll also want a weighboat. That weighboat is going to be used on our scale in order to measure the agarose. So for a 1% gel, you're going to need 1 gram per 100 milliliters of buffer. And depending on how large your gel is, you'll just scale from there. So typically these gels can hold 50 milliliters, which means that you're going to use 0.5 grams. I encourage you to do that math yourself. You'll also want to take one of these so that you can weigh it out. One thing to note is that you never put chemicals back if you overweigh them. So please don't do that for anything. In addition, our lab has buffer that is already made up for the gel itself. That is located here. It's called 1X-TAE, which stands for tris acetate EDTA. We also have a stock solution on the shelf over here, which you can use to make dilute TAE. If you ever have questions about how to do that, please ask. Okay, so what we're going to do now is just simply measure out our agarose. We're going to put it in our flask, fill that flask with the appropriate amount of buffer, and then we're going to microwave it. You will not add GelRed until after that process, because if you have bubbling over of your agarose mix into the microwave, you don't want to contaminate the microwave with that carcinogen. So we just keep those two things separate. So first, what you're going to do is turn on, and first plug it in, and turn on the scale. Okay, so it reads 0 grams, which is great. And we put our weigh boat on there and we press OT, which basically zeroes it out and accounts for the weight of that weigh boat. So what I want is 1 gram of this material, and I carefully will put it into here. And what I usually do is I just tap until I get to the appropriate amount. And again, what I'm doing is trying to get 0.5 grams because I'm making a 50 milliliter gel. Close that up, put it back on the shelf. And then what you do is just simply fold and put it in there. Okay. We turn off this and simply fill it up. So now we have our agarose and our buffer in our appropriate flask. I simply just do a little bit of mixing, open the microwave, and a volume that small will actually go into solution quite quickly. So what we're trying to do is dissolve that agarose in the buffer to make a clear solution. And so what I do is I usually press Express Cook 1, which gives it a minute, and then I check it every 20 seconds or so. You can actually watch it. It's a little bit harder on this particular microwave, but you just want it to boil enough to mix those materials. So I take it out, I swirl it. As this gets hotter, that swirling may actually induce it to boil and bubble, so you have to be careful. If you would like, you can use also a hot glove in order to prevent burning. With a volume this small, you're protected by the amount of space in between your liquid and the top. If you're using a larger amount of liquid, that often can become dangerous and it can boil over and burn you. So just be very careful about that. So right now, the material is not particularly dissolved. What I can see are bubbles as well as sort of opaque material that is indicative of the agarose not being in solution. So we'll put it in the microwave again. Give it another 20 seconds. And I can see it bubbling. So when I open the microwave, it's bubbling a little bit. What I'm going to do is grab it. It is hot, so I'm going to grab a hot mitt for myself. Grab it by the top and swirl it. And as you can see, there's a little bit of boiling happening. Now what I do is I tip it up and see whether or not there's any agar that is not in solution. There's a little bit, so I'm going to give it another maybe 2 to 3 seconds. And I can see it boiling again. I'm going to swirl it. Look at it, it looks good, and leave it until it cools just slightly so that you can touch it without a glove. So now what we're going to do is actually prepare this mold for the agarose, and the way in which we're going to do that is by using tape. So the tape will act as a barrier to not allow the agarose out of the mold. So what you're going to want to do is take a roll of tape, it can be anywhere in the lab, rip off a piece, and then place it flush with this mold. Okay? So right now, those corners are quite tight, okay? And like you're doing a very good wrapping job on a present, you're gonna fold it around, okay? And as my grandmother would say, make hospital corners. So you're gonna wrap that around and fold that over, okay? So again, what you're doing is making really, really tight connection between the tape and the mold, okay? I often will do a second piece of tape, and I will do it on top. And again, what you do is you have a nice flush amount. Before you do this with hot agarose, I encourage you to practice this several times. So I'm going to do this on the other side as well. Hospital corners. And again, do this with gloves because we're working with materials that have touched a carcinogen. And there we have it. Now, there are 2 slots that can hold your comb here. Depends on what you're running. We typically will run only one set of wells. And so you would want to put them as close to the top as possible. Okay, and they fit in snugly. If they don't fit in, that means that that comb is not meant for that particular mold. Don't try and force it, you will break something. Okay, now there are 2 schools of thought about how to pour a gel. One is that you pour the gel and then insert the comb. The other is that you can put the comb in and that gel will go around. What we're trying to avoid are large bubbles that are in that gel because material cannot move through the bubbles. So if you can pour a gel with the mold in and have no bubbles, you can do it that way. Alternatively, you can pour a gel and then add that comb later. Okay, so now we have this hot gel. Before we add it, I swirl it around and then I take out my GelRed. Okay, and again, GelRed is an intercalator that allows us to visualize the nucleic acid. It is light sensitive and it is a potential carcinogen, so we're careful with it and we keep it in a dark place. Okay, this is a 10,000x solution, so all we need is 1 microliter per gel. Okay, so I put it on here and I use the pipette that is for GelRed. Okay, and it's actually at 1 microliter, again, because in our lab, we essentially will only use 1 microliter of this. I also grab pipette tips that are labeled for GelRed. Okay? Again, this prevents cross-contamination of chemicals in the lab and ensures safety. So, what I'm going to do is just open it up, push it down, being very careful with this GelRed, pipette it out, and there we go. Okay, before I do anything, I'm going to close my GelRed up as to not spill it, and simply insert into here, pipette once, and swirl. Okay, because this pipette tip now has a potential carcinogen, we also dispose of it in a particular area, and that's in this GelRed tips only. Okay, so now our gel is ready to go. And so what I'm going to do is just simply pour it slowly, trying to avoid bubbles. Okay, after you're done with the gel, you put it up there, and you simply insert the comb into the gel. And you leave it until the gel is hardened. That typically takes 10 to 15 minutes. So our Agarose gel is now solid. One way that I test this is I actually just simply put my finger on it. If it moves at all, if your finger imprints at all, then it needs to dry a bit longer. It will also turn sort of a milky white, and that's normal, and then it's done. So to prepare it for running, you're first going to remove the comb. To do this, what you're going to do is just pull out, and you're going to do this swiftly, and it should come out quite nice. And then you're going to have these really nice wells that you can pipette into. After that, you're going to want to remove the tape. Do so with caution so as to not let the Agarose gel slip out of the mold. Okay, so that's ready to go. I then throw my tape away. and prepare this. So there's only one way to run a gel, and you're going to do that from negative to positive. So DNA has negative phosphates on the outside, and so negative and negative charges will repulse and move that DNA down the gel. So what I do is then I put my mold into my reservoir, and I bring my reservoir over to my buffer. There is a fill line on this particular reservoir so that you know when to stop. And carefully move this back over to the GelRed area. And now we're ready to pipette our samples into that gel. For your gel, you're going to use a 1 kb DNA ladder that's found in the front of this freezer on the 3rd shelf. And it will either be Promega or it will be New England Biolabs. You can use either, but don't mix them. In addition to your ladder, you're also going to need loading dye. So DNA will not actually go to the bottom of the well without some weight. And so this loading dye allows us to track where the DNA is on the gel and allow it to actually deposit on the bottom of the well before electrophoresis. So what you're going to need is the 5X loading dye, which is found in the rack on this side. So what I typically do when I'm running a gel is I first cut a piece of parafilm here so that it provides me with the ability to pipette small amounts of liquid that I'm going to then put into the gel. So what I'm going to do today is just show you how to do the DNA ladder. What we're going to do is use 1 microliter of DNA ladder and 3 microliters of loading dye. We're going to add that to our gel and run the gel via an electrical current. So just like before, we're going to use our pipetter. And what I'm going to do is take my pipette tips, make sure it's at 1 microliter, and I'm going to take the DNA ladder, make sure that it has thawed, take 1 microliter of it, and deposit that microliter onto the parafilm. This will allow us to then mix the DNA ladder with our gel loading dye and then add it to the gel. Okay, so now I'm going to deposit this pipette tip again into there, and then I'm going to add 3 microliters of loading dye. Use a new pipette tip so that you don't cross-contaminate. And then I'm going to add that 3 microliters to my droplet containing the ladder. Okay, now because the only thing in that droplet is loading dye and ladder, we're going to be adding it to the gel. I'll use the same pipette tip. I'll bring it up after I make it into 4 microliters. Bring it up into my pipette tip. Okay, and now what we're going to do is move over to our gel. We're going to find the well and insert our material. After we're done with that, we then again put our GelRed tip in there and put that away. Because again DNA is negative and what we want to do is repulse the charge, we're going to put the black negative up top, red positive on the bottom. It's really the only way it fits, but you should know the reason why. Okay, and then we're going to figure out which of these are actually attached. So I'm removing the ones that aren't attached, and then we're going to turn this box on. Just feel around. It will go on, and then you can press the power. You can run this gel at a wide variety of voltages, anywhere between 75 and 120 is appropriate. You can set it by using the set volts and then the up and down arrows. Okay, if 85 is good, it's sort of a mid-range voltage. It won't run it too fast, so you won't get streaking, but it won't take forever either. Okay, and the only thing you do after that is press run. You should hear this like buzzing. If you don't, that probably means it's not working. The other thing to make sure of is that you have active bubbling in the buffer from both the negative and the positive ends. The bubbles will be more prominent at the negative end than at the positive end, but what I do is I simply just look for those bubbles to assure that the gel is running. Additionally, you can come back every few minutes and make sure that your dye is actually running the opposite direction than where you put it. If it runs towards the gel box, meaning this way, you have your electrodes changed inappropriately, and that could actually be due to the fact that your red is not in the red here and your black is not in the black. And I've done that before, so don't worry if that happens. So after this, it will probably take anywhere between 20 to 40 minutes to run, and then what we'll do is look at it under the UV light.
To capture a gel image of your gel, first place the gel in the gel box. Close the box, turn on the UV lights. Do not open the gel box when the UV light is on. Next, turn on the software called Carestream MI on the desktop. This is the software that you use to capture your gel image. And then you click on Capture Gel on the top left corner of the screen. And it's going to start capturing the image in the gel box. So we should wait until the bar goes all the way to the right. So now I can start seeing my gel image from the screen. However, I feel like my gel is not properly aligned. I can just turn off the UV light, open the gel box, and adjust it. Close it, turn it on again, and wait for it to load again. So now my gel image looks good. So I will click Capture and Other to save the image. Once it's ready, click on File on the top left corner, choose Export Data, Image, and save it to your folder. I'll name it 5.6 Test, because today is May 6th and this is a test image. Save, exit out of Carestream, go to your folder, pull out your image, click Print. You need to turn on the printer first, don't forget. And then next. Finish. And you get your gel image that you can paste into your lab notebook. Turn off the UV light, open the gel box, take out your gel. Since you don't need it anymore, you're going to dispose of the gel. Since we use GelRed at the DNA intercalator, it's totally safe to go in the trash.